Thank you for your patience, everyone. Okay. I think we're good. Is this on? Because I'm not going to use it. No, so.
Maybe if you talk into that, it'll play over there, and then
right.
And at least they'll stop talking and try to figure it out.
Well, you know, a big part of this talk is about concurrency, and so this will be a great way for us to really get into the idea, you know, multiprocessing and concurrent processes. So, yeah, so we're good.
So is my strategy actually listen to both of you at once, or am I supposed to switch back and forth every half second?
Well, you know, you have to really avoid the context switches because it's going to kill you, and we'll get into that. But yeah, no, just focus. I don't know whether I should just try and talk louder than the speaker, if that works for everyone, or if you want to come closer, or whatever works. If you want me to speak up, just
loud and slow.
Okay. So I'm Aaron Coburn. Hang on. Let's see. Great. We're all set. So it's really destructive. I'm a sysadmin at Amherst College. I'm a programmer as well. I like cloud computing. I'm interested in distributed systems. I do this professionally. I contribute to a number of open source projects that are out there related to some of this stuff.
That's not going to affect you.
I have a thing for programming languages, so I'll mention a couple of those languages during the course of the talk. Feel free to ask me questions if I start going down a rabbit hole. Otherwise, I'm going to try to leave plenty of time at the end for questions, and then afterwards, if you want to talk to me later, feel free to. I'm going to start with a quote, which is a little passé, but and this quote is from 40 years ago from Donald Knuth, whom many of you may know. We should forget about small efficiencies, say about 97% of the time. And then, you know, the famous part is, you know, premature optimization is the root of all evil. I don't know where he gets his numbers, but and he's talking specifically about the use of goto statements in I think it's C. It might be assembler. Is Fortran? Might have been Fortran. That makes sense. In any case, if you buy his numbers, this talk is really about that 3%. Now, that 3% may be a little bigger now than back then, but this is about optimization. It's about making your website do more with fewer resources. The thing about this, and this is the point he's making here, is that once you start doing these optimizations, your infrastructure, your code, whether it's infrastructure, whatever, it suddenly gets a lot more complicated. So whereas before you might have had a really simple, very elegant solution, once you need to scale it and make it faster and bigger and more efficient, all of a sudden you have to start doing things that might make it more difficult to maintain later on. So what can we do to make it easy to maintain while also scaling? And that's what I'm going to talk about. So I'm assuming you're all really familiar with the LAMP stack. It's the beauty of the LAMP stack is it is so easy to understand. People have been using this and talking about this for many, many years. You've got a lot of people who understand it, who are it's easy to install, it's easy to maintain, it's great. But the problem is eventually, if you're successful, you're going to need to scale this. Now, it may be that you don't need to scale, and if you don't need to scale this, just leave it like it is, keep it simple. If you have to scale, there are basically two ways of scaling. There's the vertical scaling and the horizontal scaling. I'm going to just talk a little about the vertical scaling just to contrast it with the horizontal scaling, which is what we're really going to be talking about. So it used to be the case that, so vertical scaling means you have one server, it used to be on one server, still on one server, just a bigger server. You've got more RAM, you've got faster CPUs, you've got whatever, but it's just bigger. Now it used to be that about every 18 months, processors got a lot faster. Clock speeds were doubling about every 18 months to 2 years. So you could buy a new server, and without changing a single line of code, your site was faster, maybe even twice as fast, which managers certainly loved, programmers loved, because you didn't have to do anything. It was a free lunch. Maybe you just needed to add a little bit of additional RAM. So that worked for a while. Most of this conference is about software and management of software, so I'm going to talk just a little bit about hardware, because this is really, really important stuff. If you this green line here, this is transistors per CPU chip. So we're getting a lot more power on each chip, and that's happening each year. This goes through about 2010, and this is a logarithmic scale here. So 1, 10, and then we're up here to 10 million. So there's a funny thing that happened to clock speeds right around 2002, 2003, which is that they plateaued. Processors are not getting faster, and they will not get faster. I mean, there's some interesting research being done on these really weird kinds of polymers and whatnot, but until something new, fundamentally new, is invented, clock speed, so the speed of your CPU is going to stay the same. So what's happening here is that you're getting more processors, so more cores on a chip, which means that your programs can increasingly, in order to make use of that additional power, they have to be run in parallel. And programming in parallel is hard. Has anyone here, just a quick poll, has anyone here ever done either multi-threaded or multi-processor concurrent programming? C, Java, C++, yep, little. So great. And as you know, it's really rough. People have been doing this for 20, 30 years, and there are certain kinds of, under high load and high numbers of parallelism, you can run into some really difficult bottlenecks, deadlocks, those sorts of things. So you have to be a little bit careful about how parallelism works. So in contrast to scaling vertically, the other option is scaling horizontally. What that means is that instead of whereas before we had one server, now we've got 10, 20, 100. So now all of a sudden you've got a lot more horsepower, and if you've got now 100 servers, you have to remember it's 100 times more likely that one of them is going to fail. So when you build these kinds of things, you need to build in some understanding of fault tolerance so that when it fails, doesn't matter. I mean, you'll get to it, it'll be fine, but it's not going to bring down the whole site. If you look back at the LAMP stack here, on one machine, even on one machine, if any of those components fails, the whole thing, it's game over. If your database server fails for some reason, you're toast. If Apache dies, you're toast. If your file system becomes corrupt, same thing. So again, you have to have fault tolerance. So I'm going to just talk a little bit about fault tolerance, how you can deal with that. The trivial example is, okay, well, we can pull MySQL out and we can put MySQL in a separate box, and okay, that's It's going to buy you some additional time in terms of RAM and in terms of CPU utilization. But even this doesn't eliminate any of your single points of failure. So even with this, if MySQL dies, again, the same thing works, or the same thing doesn't work. One thing that people do, and this isn't exactly the ideal scenario, but this is one sort of a simple sort of building up, walk before you run kind of thing, is having a reverse proxy. So you have a request coming in to a web server. That request is then proxied to multiple backends. There are a number of different kinds of proxy servers that you can use. Nginx is a very popular one. It's one that I use and am very familiar with, and I can definitely would definitely encourage you to use. HA proxy is, I also use that in different contexts. HA proxy is just a proxy. It stands for high availability. It's really good. It's really fast, but all it does is proxy. So the nice thing about Nginx is that it will do your it's actually an HTTP web server, so it will handle it speaks HTTP, whereas HA proxy just speaks TCP. So, but the idea here is you have multiple backends, and then you can decide whether it's going to be a round robin. So the first request goes over there, the next request there, the next request over there, and it just cycles through. If one of those backends goes down, it just if the one here on the left goes down, requests will only go to the two on the right. And then eventually, when you bring up the one on the left, it comes back. That works pretty well. You have to remember that you need a clustered and high available file system behind that, because if, for example, you have a user who uploads a profile photo over here on the left, the server that's over here on the right, if that goes into a directory somewhere, the server over here on the right needs to have access to that. And you can use different things like Amazon S3, or you can use Swift from OpenStack, or other kinds of distributed, file or blob storage engines. And there are a lot that are available. So here, if you're doing pure read throughput and TCP connections, you're going to be able to support a lot more users. But in terms of write throughput to the database, you've still got one common database, and so it may not actually be a lot faster. With MySQL, if you're going to stay with MySQL, which, as you know, is a relational database system, they've been around for a very long time. There are a lot of advantages to relational database systems. They don't do so well in the context of distributing across multiple systems, but we'll get into that. If your goal is fault tolerance with MySQL, MySQL will help you with that, and you can build a MySQL cluster pretty easily that will do fault tolerance. So basically, the model is this, where you have a master. Anything that's written to the master is then propagated to the slaves. You can have any number of slaves. Here we've got 3. If the master dies, one of those slaves becomes the new master and sort of is pushed back up on top. If a slave dies, who cares? So basically, but the thing is, all of the data is replicated on every server. So if you've got 4 servers here, you've got 4 full copies of the entire database. So again, one thing you can do now, in theory, what you can do is you can have your application do all the writes to the master, but then reads can come from any of the slave servers. Now, in practice, that turns out to be somewhat tricky, and not a lot of applications support that. If you're using WordPress, there is a module, and I've never actually used this module because I haven't had a need for it, but I believe it's called HyperDB, which modifies how some of the database calls are done in WordPress so that any write goes to the master, and then any reads come from one of the multiple slave servers that you have set up. And so you can just install that and run it. I've heard good things about it, but I haven't actually used it. So this is a fairly standard topology for doing this. So again, the positive thing here is you can tolerate node failure. You can your sysadmin can sleep at night, and you've eliminated any single point of failure, more or less. Your site may not be a lot faster though. So most of the rest of this is going to be about concurrency. Concurrency is, in my opinion, the big issue in systems right now. In scaling systems, in writing systems, in high-performance systems, in distributed systems, concurrency is where a lot of the research and a lot of the effort is going. And the good news is that there's a lot of really great software out there that's going to help you. The downside is it's going to be a lot more complicated, and you're going to need to depart from the LAMP stack to do it. At least I'm going to assert that. So there are a couple things. When I say concurrency, basically what I mean is you've got a lot of things going on at the same time. It's a little bit different than parallelism, where you've got machine-level executions happening at precisely the same moment. But you can have concurrency where, for example, you're doing a database call, and while you're waiting for the results to come back, you're also doing something else. And I've got some examples of sort of what that looks like in the context of PHP and what that looks like in a different language. But in any case, concurrency is what people mean when they start talking about web scale and lots of users. There are, in my experience, there are really two things that you need to really concern yourself with when dealing with high levels of concurrency. The first one is the amount of RAM you're using per connection. And then the second one is shared state. And this is going to apply not just to web servers, not just to, basically to anything that's going to try to manage some sort of large amounts of concurrent use of a particular system. When I say RAM per connection, what I'm talking about specifically is when your browser opens up a web page, what happens is, it first loads the HTML. Inside the HTML, you're going to have images. You're going to have all sorts of static files like style sheets, JavaScript, etc., etc. Basically, the HTTP model is a request-reply model. It's stateless, which means it makes a request, it gets back a response, and that is independent of any other request that's made. Now, it's a little more complicated than that, because the way web servers work is when you make that HTTP request, you're going to be using a TCP connection, and TCP connections there's a sort of startup cost to making those connections. So rather than making a new connection every time you need to get a new image or a new style sheet file, it leaves those connections open, or at least you should be leaving those connections open. So when you make this request, it sends a request, gets a response, but then it leaves that connection open for a few seconds. And then if you have another request, it'll use that same connection and get back other things. That may be changing with, well, it will be changing with So this is HTTP 1.1, the specification, which is in use right now, and has been in use for a good long time. The 2.0 draft for HTTP is coming very, very soon, as in this fall. It's in its final draft form, and it's going to allow you to do a lot of different things. Mostly it's going to allow you to do multiplexing. So you can do you can open up one TCP connection, and you can use that one connection and make lots and lots of requests simultaneously in that connection. And it's going to speed things up considerably, and it's also going to make certain things a lot easier. But I'm not going to talk about that. So the thing to remember is when you make these connections, there's going to be a certain amount of RAM used just to maintain that connection, just to create the connection and to maintain it. And then there's a question of how long does that connection persist after the request has been made? Because from a user perspective, it's just give me this, I get back that. But what happens on the server between the receipt of that request and sending back the response, and then dealing with that connection afterwards? So first of all, one model that's the standard part of the LAMP stack. You have PHP, you have Apache. Quick poll: how many people are not using Apache? Nginx? How many people are using PHP with Apache? Lots of you. Are you using mod PHP? Yep. No. You're using FastCGI?
We were initially using the CGI. Aqua is making a concerted effort to move to FPM because it's more efficient resourcing.
Yep. Cool. So there are different ways. So if you're using PHP, there are different ways of getting PHP to work with a web server. The standard model is using Apache. Why is that? Apache is very easy to set up. It's been around forever. Mod PHP. So Apache works with these modules that you can load, and those modules fit in with your. So basically, every connection that Apache is handling has these modules for PHP. With mod PHP, you have the whole PHP runtime interpreter, etc., loaded up in those connections. So it basically bundles your web server with PHP so that the communication between HTTP request and PHP execution is very fast. Like there's not a lot of, it doesn't have to go very far to get to that. With FastCGI, which the guy in the back was using, you're actually externalizing that. And there's some huge performance gains that you can get with that. And I'm going to show you why. So first of all, with PHP, the way the language works, so PHP execution is actually quite fast. If you just do pure execution of the code, compare it to any other scripting language that you might want to consider, it's going to be pretty much, as fast as anything else. I'm not a big PHP fan, so if I make disparaging comments, take it with a grain of salt. But the way PHP works is effectively you make a request. Let's say IO here. You make a database request. You wait. The database request comes back. You do something with it. Maybe you read a file. More IO. You wait. File comes back. Now you don't wait for a long time, but you're waiting. You do more CPU, more IO, more CPU. So you have this pipeline. This is basically called blocking IO. So you do your, and you wait for it to come back. If you have multiple requests, so with Apache, one of them, the standard build of Apache uses something called mod prefork, which means that for every connection to Apache, you're going to have one dedicated process, sort of operating system level process that handles that connection. The thing to remember about operating level system processes is that they're not actually that lightweight. So they have to start up. They have their own allocation of memory and their own stack and everything like that. So allocating these is a little bit expensive in terms of computational resources. And so what Apache does is it pre-allocates. It sort of spins up 20 in the background. You can configure it all sorts of different ways, but it spins up a bunch, and then so those are just sitting there waiting for connections to come in. When a connection does, the main process just hands it off to one of them that's free. So in that model and mod prefork is kind of the standard way of doing. It's the only way of using mod PHP, embedding PHP inside of Apache. But it's also kind of the standard way people have been using Apache for a very long time. So here, each of these requests is going to be a separate process on your operating system. Each of them is going to use I/O. Each of them is going to be using CPU. And as the process proceeds, it's going to be using memory, more and more and more memory. So over the course of the process, the memory is going to sort of balloon, and then it will drop off at the end as it gets garbage collected. But you see here what's going on right here. Nothing's going on. You're just waiting. Your system is just waiting. And while it's waiting, you're consuming all the memory that you've been carrying around. So, you know, if you're walking around with these big giant buckets of water, for example, and then you have to carry it to the other side of the room, and then you get to the third table there, and they say wait. You wait. You're holding the buckets of water. It's not a very efficient model, but that's the way it works. If you've got only 2 cores or 2 CPUs, you can only have parallelism like this. So this one here has got to wait until this CPU frees up, and then it can execute. So basically, you get that kind of you get a certain amount of efficiency there because you can parallelize the use of the CPU in that regard, but you still end up with a lot of waiting around. So the other thing with Apache prefork is that any request could potentially serve a PHP file. So Apache is really, really fast with static files, as you should know. And serving a static file is not very CPU intensive. It's just you open up a file descriptor and you stream data out. It doesn't take a lot of resources. But if you're using mod prefork, every single request, whether it's a static file or not, has to have the whole PHP execution engine loaded, which carries with it a lot of additional memory and a lot of additional overhead. So, so you end up with a situation like this, where again you're using even more memory. And it's really easy, especially if your site has a lot of static files, a lot of images, especially, it's really easy for your CPU and memory to just max out really quickly under what you might imagine to be a fairly light load. There's something called fast CGI or FCGI, which basically what that does is rather than running PHP inside of Apache, you're going to run PHP outside of Apache and let this external process manage its own PHP things, PHP processes. What that means is that Apache is only going to be doing I/O. It's going to handle your connections and it's going to do I/O. So for these here that were just handling static files, they don't have the whole PHP overhead involved, and those processes that do have PHP involved, those processes are then sent off to FCGI or fast CGI in the background. So that ends up being a big win. Again, without changing any of your code, any site that's currently using PHP and Apache can do this. if you're using Nginx, you have to do this. So Nginx doesn't allow you to embed PHP in the web server. It has a lot to do with the model of how Nginx actually executes code or actually executes requests and processes them. But basically, if you're using Nginx, which is a really, really excellent web server for anything, most anything, you're going to need to use FCGI or FastCGI. PHP, they have a new kind of packaging system called FPM, the FastCGI Process Manager for PHP, and it's getting easier and easier to install that from existing repositories and to get it up and running on your system. So just the easy thing to do, again, without getting crazy about any of this other stuff that I'm going to get into, you can do this and your site will be a lot more efficient. As a counterpoint, I'm going to talk a little bit about Node.js, Nginx, and how those two work. Node has a very different model of execution, and they're both event-driven. So with Nginx, with Apache, remember we had multiple processes. With Apache, you can also have, instead of multiple processes, you can have multiple threads, which is, instead of npm prefork, you have npm worker, which is if you're using FCGI, you might as well be using npm worker because you don't need a whole process for each connection. And that makes a lot of sense. Nginx goes one step further, and it's event-driven. So there's a single thread, and whenever something happens, an event is triggered. What happens with this is that you're able to suddenly support a lot more connections with fewer resources. If you're using PHP in the back end, what happens is you have a connection come into Nginx, and then the request is just sort of streamed off to your back end, whether it's PHP or, in this case, I'm going to describe a little bit about Node.js. But basically, you can Node.js is very similar, where again it's also event-driven. It's also single-threaded. So if you have multiple cores, if you have a machine with, say, 16 cores, you might give 2 of those cores to Nginx, and then the remainder 14 to various node processes each. And so then Nginx will act as a reverse proxy, doing round robin or some kind of a proxy to those requests, and then each request by node effectively takes over one CPU and then and sends those responses back. The other thing about Node that's really different than PHP, if you're familiar with PHP, is that it's asynchronous, and the I/O is non-blocking. So what it looks like is, instead of having one long line where you do I/O, you wait, you do your CPU, then you do more I/O, you wait, more CPU. You don't wait. I mean, you can write Node.js code that involves exactly the same kind of waiting and processing, and followed by more waiting. But if you write it correctly or properly, it's going to you can send off. You can dispatch a bunch of I/O requests, and as they come back in, you process them. So your CPU, all of a sudden, the lifespan of those gets collapsed tremendously. So even though the actual processing may not be a lot more complicated than with PHP, the way you execute the process ends up being a lot faster. So you're able to serve more requests. Because each request is faster, the memory used in each request is going to therefore be around on the server for less time, which means that you can consequently serve even more requests. The disadvantage with Node.js, if you've ever worked with it, is you end up with this what people call boomerang code, where you have a function, then you have a callback, another function, a callback, and so your code starts kind of creeping out to the right a lot faster than it actually does anything. Some people call this the pyramid of doom. Some people have less flattering things to say about it, as you can imagine. So there are ways around that using promises and whatnot, but I need to move along. So concurrency and shared state. This is the other main thing that's going to kill you with concurrency. And by shared state, I basically mean database. So holding data that any of your processes can access. The typical way of doing this, and this is how it's done with relational databases, is using locks. So with relational databases, you can do these lovely joins and all these really incredible ad hoc queries. But if you're joining across, say, 5 different tables, and someone happens to be writing to one of those tables that you need access to, well, the whole that request that involves that join is going to wait until this write operation finishes, and there's nothing you can do about it. So you're just going to end up waiting a lot. And if you have more and more concurrent requests while write operations are happening, you're going to sort of back up these access requests even more. And so there's just going to be more waiting, and potentially your site's going to be even slower. So, you know, again, MySQL, depending on what you're doing, there are a lot of real advantages to using it. It's very powerful. The thing about consistency and durability is when you make a write to MySQL, you have a certain set of guarantees that that write actually succeeded. It was actually written to disk, and that whole process, that whole transaction succeeded. There are other systems that are going to be a lot faster that might buffer these writes in memory, and they'll respond even before that write makes it down to disk, which means that they're going to be a lot faster, but they're not going to be as quote-unquote durable. But MySQL is going to be very durable, and it's going to be very consistent. There are a lot of people who like MySQL a lot. Maybe they need to use MySQL, and they realize that in order to make it a lot faster, the thing they can do is they can simply denormalize their tables. So rather than having all these joins, you put everything into one big table, and you no longer need to join anymore. And so people have been doing that. It also allows you to shard this across multiple servers, which, again, you can do in MySQL. But then all of a sudden, it's no longer a relational database. You're making a relational database do things that all of these NoSQL databases are now just doing out of the box. So with NoSQL, people have been doing this now for many years. Basically, you relax a lot of the constraints that relational databases impose on data, and you basically make it fast, hugely scalable, and hugely distributable. The great thing about NoSQL systems is there are a lot of options out there. So whereas before you had lots of different flavors of relational databases, which are more or less the same, you know, you can quibble about how Oracle compares to SQL Server, but they're fundamentally the same. Whereas something like CouchDB versus MongoDB versus DynamoDB versus Cassandra, they're fundamentally different. They might look kind of similar in certain respects, but the only thing I would say is don't just use MongoDB because everyone else is using it. You know, figure out what you need to do in your application, and figure out which database is actually going to handle that better than the other databases. I mean, MongoDB is great. I think it's great, and especially if you're coming from a world of MySQL and relational database systems, it's perhaps a lot easier than jumping right into MapReduce kinds of queries. So that's great. I'm kind of out of time now because I started late. So I'm going to race through one more thing, and I'll skip the last part. If that's not fast enough for you, if writing to a denormalized possibly distributed NoSQL database isn't fast enough for you, there is yet another thing you can add to this mix. Again, if you need it, which is complete asynchronous writes. And basically, the idea here is rather than having your scripting language write directly to the database and then get a response back, it simply writes to a queue, and that queue gets processed later. And this is really good, for example, with a search engine. Let's say you change a page on Drupal. Now, the content needs to be sent to, let's say you're using Solr, which has been externalized. Solr is fabulous. Now, the request doesn't really need to send all the data to Solr, commit the change to Solr, and then return for PHP to then continue, because you're going to get a lot of I/O blocking there. What you can do is you can simply say, hey, and you send that to a messaging system, and your messaging system will then end up processing it later. It means that your Solr search engine is going to be a little bit out of sync from your core application, but you might decide that that's okay. I personally would decide that that's okay. Messaging, you all are very familiar with it, even if you've never heard of it before. It's exactly like sending a text to your buddy. It's exactly like sending an email somewhere. It's an asynchronous form of communication. It's like, hey, let's meet up after work, whatever. With application messaging, it's exactly the same thing. It's just that you're sending maybe XML, or you're sending JSON, or you're just sending some kind of data from one computer to another computer. But rather than having one system send it, having, say, Drupal send directly to Solr, you decouple that, and you put this broker in between. So Drupal or WordPress or whatever your application happens to be sends a message to your message system, and there are a lot of messaging systems out there. There's RabbitMQ, there's ActiveMQ, and then you can have a consumer that reads basically off of this queue and processes as needed. And you can distribute the load and have lots of things happening. And it's really, you can have multiple producers, and you can have all kinds of interesting scaling happening. Let's see, I'm going to skip that. Languages for concurrency, there are some languages that are better for handling concurrency than others, but I will leave that for some other time. Questions?
The fast CGI PHP, how does that differ from fast CGI Perl? Are there sort of construction constraints where you have to develop your application a certain way?
Not that I know of. I mean, it's basically a container where you're running the application. So if it's Perl, fast CGI is just going to manage that, per application. I haven't ever used Perl in fast CGI, so I would assume that it's going to be the same.
Yeah, some legacy code, and we just had trouble coming up to speed for what the previous developer had done.
Mm-hmm.
So we're a little light on that.
Okay. Yeah. Yeah.
I'm just going back to what you said about Node.js being asynchronous. It's single-threaded but simultaneous. Like, how can something be single-threaded and simultaneous?
So the you're not doing machine-level parallelism. So you're not having two CPU kinds of operations happening. But what you're doing is you're saying, go out and do this database query, and then also read this file from the file system. Now, the first one that comes back, once it comes back, handle that. When you're done handling that, you'll handle this other thing that comes whenever it comes back. So you basically dispatch these events. So read this file, go get this thing. So one example would be, let's say you want to read content from 5 different web pages. right? So your network I/O is going to be big. Your processing I/O is going to be really, or your processing is going to be really small. So go out and get, the content of Google.com and Facebook or whatever, and so on and so forth. So basically, concurrently, it's going out and making these requests, and then whenever they come back in, it will process them. So let's say each request takes approximately a half second of network I/O, and then basically nothing for CPU. So rather than sort of adding all of the network I/O load across each of those requests, sort of sequentially, what you do is you collapse the I/O, and so then it's just going to be a question of what is the longest I/O request, and that's the total amount of time that it takes, plus your little tiny bit of CPU. That's the point is that most web applications are fundamentally about I/O because again, database calls, network calls, go back and get this thing from an API, whatever. There's a lot of I/O going on, and there's really not a lot of CPU. I mean, you're not cranking out like crazy linear algebra stuff. It's just you're getting data from other places, and that's what gets collapsed. Yeah.
So if we're using a framework like Drupal or WordPress, you could switch to fast CGI. But is there much we can do with databases, or it seems to me we're pretty much tied to?
Yeah, you're a little tied to that. There's a lot of flexibility. You might know more about this than I do, but basically,
from a Drupal standpoint,
yeah.
I definitely know a bit more about that. My name is James, by the way. If you can find me after the talk, I can speak a little bit more about it from an ops perspective.
Mm-hmm.
Unless you want me to, I can cover it real fast.
Yeah, I mean, basically, you can use Mongo in Drupal.
So, having had prior experience supporting a Mongo environment that wasn't terribly great, my opinion of NoSQL databases is a bit colored. So take that as you will. But point being, if you're still on a MySQL database and you're trying to run a Drupal WordPress site up in front, the way that we're doing it right now is you basically have a pair of MySQL databases in master state, and it's binlog replicated between the two, separated by availability zones, since we are primarily in Amazon Web Services. You could do the same thing if you're on bare metal and you want to be separated by data centers physically. You just have to secure it by SSL or something like that. But you can run master. You just have to figure out how you want to fail over, either via DNS pointing or some other mechanism like a load balancer up front. I know some load balancers will allow you to do something very close to that. I haven't touched F5 since a while. I don't know if that's still a thing.
Yeah, I'm not sure about that. But yeah, I mean, there's another thing you can do is you could put a caching proxy in front, so something like Varnish, if you want. I think those are a little sketchy, just because you have to figure out how you're gonna sort of, when you have changes in the background, how do you just make sure that change propagates out to the cache.
Binlog is fairly good at that. From a single MySQL instance to a MySQL instance, it's fairly good. Just the problems come in when you start extremely large data sets. I mean, like, binlogging is great if you're going up like maybe 50 gigs total of MySQL data. You start getting like hundreds of gigabytes of total data, MySQL database data, and it becomes much more complex, especially over long distances in terms of network topography, different settings for binlogging, etc. It can be quite complex, but if your data set is small, it works. And transaction replication. I can only speak about
Yeah, I mean, if your database, I mean, if your data can fit on a database pretty easily, MySQL can be tuned to be pretty good. If you truly have data that needs to be spread across multiple machines because you cannot fit it on a single machine, that's where you're going to need to look at a different kind of thing. But you probably shouldn't be using Drupal at that point.
Well, yeah. If your data set's that big, Drupal is probably not the correct solution.
Yeah.
I mean, depends on what you're storing, depends on what you're accessing it for, et cetera, et cetera. I mean, if it's like you're into some big data thing, you'd probably be better off setting up a different application and then providing a REST API or something that's call and pull information out of that and using that as a separate application entirely, separate from these two applications. That's a conversation. If you want to have that outside of that, myself or actually we find Eric Peterson somewhere on the floor, more than happy to talk.
Cool. All right. If you have other questions, feel free to catch me. So.